Okay, thank you to everybody who is here already. I look forward to this presentation for you all. We're going to start, I think, about now. People can continue trickling in, and as I'll remind folks throughout, we will be recording this. We will be sending a follow-up email later today or tomorrow with the recording, slide deck, and demo so that everyone can review it. You can share it with your colleagues who were unable to be here. And please place all of your questions for the host to answer in the question and answer box. So at the bottom of your screens, there will be a Q&A box. Please place your questions there. It'll be easier to track them and respond to them directly in comparison to if they're being put in the chat box. And we'll remind folks of that throughout. Without further ado, Boris, if you want to start the slide presentation, I can do a quick introduction and then we can begin.
Does it work better in this screen, or is it better when I do full screen?
I think full screen is probably good, at least for the interim. And then when we begin the demo, we can exit full screen, obviously. They're still a little small. If we can make them any bigger, that would be
great. Maybe this one's better. Kind of when you go into full screen, it shows your whole screen, so it looks very small.
How about now?
Yeah, this is better, I think.
Just move to another monitor. So you can see my screen. It says
yeah. Okay, that's perfect. Okay, great.
Perfect.
So I'm Sophie. I am a developer advocate here at Pinecone, and presenting today on our ML-based applications for semantic search webinar will be Boris Power, a technical staff member from OpenAI, and James Briggs, our senior developer advocate here at Pinecone. So if we go to the next slide, I'll share the agenda quickly, and then we'll move directly into the presentation. Great, here's our agenda. We'll be going over some of the key components of using OpenAI and Pinecone for building semantic applications, and then we'll have a demo with using OpenAI and Pinecone that you will also receive in your email tomorrow or later today so that you can play around with it as well. And with that, I'm going to pass it over to Boris and James to take us away.
So yeah, I want to say a little bit about embeddings and what they are and how they work and what they do. So embeddings is a concept that encodes semantic meaning of a piece of text into a vector of numbers. So what that means is that given either a short sentence or given 2 pages of text, in this case, if you, for example, embed where is the Bank of England, we get a vector, which is a sequence of numbers, and we can look how close is that in a multidimensional space to other embeddings. So in this case, we have where is the greasy bank, how does a plane bank? So these are 3 sentences. Each time bank means a different thing, and these map to 3 different parts of the space. However, when we have a description that means a very similar thing, even without using any of the same words, so in this case, the bees decided to have a mutiny against their queen, and flying stinging insects rebelled in opposition to the matriarch, these 2 will in the embedding space be very close to each other. So basically, if 2 pieces of text are similar to each other, they will also be similar. Their embeddings, which is their numerical representations, will also be similar. If there are any questions, please feel free to put them in the answers, but I'll pass on to James now.
Yeah, so just continuing on from what Boris went through there, in order to create those or map that text to the vector space that you saw, we use what are called embedding models, which Boris will talk about a lot more later on. And then in order to use those sort of embeddings in a in a tool like semantic search, there is another component which are vector databases. And those vector databases are where we would store those vectors. And I'll go through a few other things that makes a vector database soon as well. But using both those embedding models and vector databases together, we're able to build cool things such as semantic search, where we're basically searching for searching based on meaning rather than sort of term matching that you may have used in the past. Okay, next slide, Boris. So let's try to here kind of visualize what I mean when we use this embedding model or encoder to take some text and map them into a vector space. So in this case, we're not just mapping sentences that are similar, but we're also mapping a query and a sentence that kind of answers that query for us as well. So it doesn't necessarily need to be two sentences. It can be different things like pairs of questions and answers, or many other things that you could apply to the sort of search or want to compare. So move on to the next slide. So once we have those vectors, this is where the sort of vector database part comes into it. So we put all our vectors into a vector database, and you can imagine this as being like a 2D or 3D space, although in reality there's many more dimensions in these vectors, but we'll go 2D or 3D. So we map those in that 2D or 3D space, and the similar ones, as we saw before, are very close together. And what we can then do is, given a particular query, we map that using the same embedding model as what we used before into our vector space, which is all stored within our vector database. And then we look at what the most similar other vectors within that vector space are. And they are essentially what we would view as being the most relevant items to our particular query. Okay, and then we can return those to the user. So we move on to the next slide. So that's like the core function of a vector database, but there are many other components that make a vector database like Pinecone particularly useful and helpful in our use cases. So one of the key components of that is what we would call approximate search versus exhaustive search. So imagine you have millions of items and you want to search through all those millions of items for one particular query. Using an exhaustive search, you literally have to compare everything. So you have all these millions of items and you're doing millions of comparisons every time you want to search through that data. And that might be okay for a small number of items, but as soon as you get into the multi-million or even billion range, it's going to become very slow. So you have to start using what is called approximate search. And like any sort of scalable vector database needs to be able to support approximate search. So go on to the next slide. Another thing that I think is really important and that Pinecone has done very well is having an instant refresh of your vectors. So when I say instant refresh here is literally you are waiting, I think, something like 5 milliseconds in an index that contains millions of vectors. You can upload a set of new, maybe you can even upload like 1,000 new vectors. And then 5 milliseconds later, you can query the vector database and actually return one of those newly uploaded vectors, which is very hard to do, but incredibly useful especially when you're looking at near real-time data. Next slide, please. Another incredibly useful component of a good vector database is metadata filtering. So you imagine you have all of your vectors, and they might have some particular piece of information connected to them. So maybe that could be things like dates. It could be particular categories for your vectors. Like maybe in some of your vectors, you are storing documents. Some of those documents are from the engineering team. Some of them are from HR. Some of them are from finance. And maybe what you want to do is, for your particular query, you want to say, okay, I only want to search through the engineering documents. So with metadata filtering, you can do that. And with Pinecone's single stage filtering, you can do that incredibly quickly. So you can get very accurate results with a filter applied. And actually, in most cases, applying your filter is going to make your search even faster, which is something that's, again, very hard to find. Yeah, now we can move on to the next slide. And yeah, so they're sort of the key components of a vector database. And as I said, it's one part of the sort of pillar of semantic search. But now I'll pass over to Boris, who's going to talk a bit more about the other pillar, which is all of your embeddings.
Yeah, thank you very much. So what we talked so far was embeddings. So I just wanted to expand the scope a little bit, just to explain what OpenAI API is and how that connects to GPT-3 and then all the other endpoints that we now offer. That's sometimes a source of confusion. So OpenAI first started off as a research company. And then about 2 years ago, we transitioned and we created an applied team, which released an API. And through that API, we started serving GPT-3. And GPT-3 is a large language model, which is autoregressive. So what it means is that basically it predicts the next token, which is roughly the next word, given all the previous words. And then it keeps doing that recursively. So what you can do is you can give it a prompt. So give it some starting text. So for example, once in a while, comma, then the model will try to complete in the most likely way what words are likely to come next. So that's how it started off. And what we did to this model, this is the model that hasn't been, it's kind of what we call a raw base model. And this is similar to what we released with GPT-2 in open source as well. What we did to make that model a lot more useful is we trained this model to be very good at following instructions written by humans. So what that means is if you write instructions, you tell the model, write me a poem about Pinecone and OpenAI integration, the model will do its best to fulfill that instruction as a human would if they were given to that instruction. So you can also ask other things. You can say, extract entities from the following text, or you can even specify much more clearly, extract all Fortune 500 companies from the following text, and for each of the companies in brackets mention if the sentiment is positive or negative. And the model will be able to understand those instructions and give you a bullet point list of all the companies which are Fortune 500, and in the bracket, it will give you the sentiment, either positive or negative. And that's the instruction following. Fine-tuning is an ability to customize the model, so you can get your own version of a GPT-3 model that is trained on your own data. So you can specify what inputs and outputs you want. You can create a fine-tuned model, and that is then served through an API. And then recently, we also released the edit and insert capabilities. So these are the capabilities when you have a piece of text and you want to make some change to it. So what you do is you give a piece of text, and then you also give it an instruction for how you want to modify it. So you can, let's say you have a piece of text, you say, change it to a third person. That should hopefully change it to a third person speaker. And insert is a model, is a endpoint where you know what comes before and you know what comes after, and you want to just insert something in the middle. This is quite useful if you want to create a writing assistant where you have some paragraphs, and let's say that you're editing somewhere in the middle of the document. You want to predict the next word, but you also want to know what comes after, because you don't want to just kind of repeat the words that are already in the paragraph following that. So embeddings is what we'll focus on today. And this demo is built using the only embeddings and instruction following. So we use the embeddings, as James explained, to find the most similar context given the query. And then we use the instruction following to produce the answer as based on the instruction, such that it satisfies, given the context that's been retrieved. So what are OpenAI embeddings? So OpenAI embeddings are the most powerful embeddings that are general and applied to all the different tasks. And they work both for language and code, and they embed both language and code into the same embedding space. So if you want to do things like retrieve, like where is the server, the app server implemented, even if the code is not very nicely named, the model will still be able to understand the code and then retrieve what are the most likely places where this exists. And what's other thing that's unique about OpenAI embeddings is that they're up to 2 to 3 pages in length that you can embed. So other open source embeddings generally can embed maybe 1 sentence or just a small paragraph. So we can go larger. And the other thing is the embeddings themselves come in a much higher dimensionality. So given the size of the embeddings that you want from OpenAI, you can either get 1,000 numbers, 2,000 numbers, 4,000 numbers, or 10,000 or 12,000 numbers. And what that means is that basically the semantic representation contains a lot more information in those larger embeddings. And also what you can do is you can fine tune those embeddings yourself if you have a specialized data set. So one of the questions that I liked was, would love to know the best practices to handle lexical do the embeddings include stylistic information? Could you search for text with a similar style? So let me just try to answer that question right now. So the embeddings themselves contain a lot of information. So primarily they're focusing on the semantic similarity, but they'll also contain in those, let's say 4,000 dimensions, some of those dimensions might be representing the stylistic information, or some combinations of dimensions might be represented. So if you have a data set of, for example, 100 or 200 examples of which styles are similar to each other and which styles are not similar to each other, you can then learn your own transition matrix that you can apply to the original embedding space, such that those things that you find similar end up being closer in that destination embedding space, and those things that are dissimilar end up being further away. And that way, what you can do is you can kind of change what you mean by similarity of vectors. You may not mean semantic similarity anymore. You may mean a lot more about stylistic similarity. So that's I think an interesting area of research, and we've seen some success there of being able to identify authors of texts with some, with some precision that is better than random. So yeah, we have 3 families of embeddings, and one of them is the search. It's used for search. The other one is used for similarity, and the other one is used for code. So why do we have 3 different families? Largely because these are 3 different use cases, and they are specialized in a slightly different thing. So with similarity, you're comparing like for like. So you're taking a document of, let's say, 2 pages, and you want to find what are the other near duplicates to that document. Whereas with search, what you want is, if I have a document of 2 pages, and if I have a query which matches only maybe the first paragraph or the last paragraph of that document, those 2 things should be similar to each other. So these 2 are slightly different similarity functions, because you can think of the search as almost the query can be a subset of the larger document. And that's why we have 2 separate models, and then code search is just kind of specialized in the code tasks. And for this demo, we'll be using the search embeddings. So there was a question about context, and I'm not sure. I've seen a question around the context and the query embeddings, so that's exactly what happens in the search endpoint. So what we use is we use the context embeddings to embed the larger questions, and then we use, or like the larger documents, and then we use the query embeddings to embed the query that the person writes in the text box, which is generally much shorter than those documents. And this is already spoke about different models with different costs associated with them, and then different dimensionalities. And I find that Babbage and Curie are already better than other general embedding models. So I normally wouldn't go for DaVinci unless you have a very strong case for doing so, because dealing with these many dimensions makes other things a lot more challenging as well. And James, do you want to kind of explain the app itself?
Yeah, so what we have here is essentially an overview of what we're going to be demoing. So in the top left, you can see all those sort of like web browser windows. They're representing the web pages that we have scraped data from. So we've looked at the community pages for different ML frameworks like PyTorch and TensorFlow and Hugging Face. And what we've done is taken the text from there and then fed them into a OpenAI embedding model to create these embeddings and then store them in the Pinecone vector database. Now that's just, we do that step when we're indexing data. So when we're sort of initializing our tool or our project, or we're bringing new data in, that's when we perform this sort of indexing step. And then on the other side, on the right, you see we have this sort of querying step. So at the top, we have a little search bar, and we can ask questions like, how do I use the gradient tape in TensorFlow? This query is then passed to OpenAI's embedding model and converted into the query embedding, which is passed to Pinecone. We do the vector search as we sort of visualized earlier, and that retrieves a set of context vectors. Those context vectors are then formatted in a particular way. So we have several different contexts from different sources. They're formatted as well or alongside a particular question, like it's almost if you're asking a person a question and you're giving them this context as well. That's kind of how I would describe it. So you're asking this very like human question, and then you're saying base your question on the information you are getting from these contexts, and then we pass that into OpenAI's generation model, and then it like returns this very sort of like human, like readable description of your particular or answer to your particular question. And there are also one thing that is not sort of visualized here is that we can change the style of the question, which I'm sure Boris will show you soon, but that's also a very interesting like thing you can do with all of this. So yeah, this is how the app is built at a high level, and I think now Boris will sort of show you what it actually does.
Great, and if you want to look at the demo yourself, you can have a look here. And there's also some get started material. I assume that we'll be sharing the slides afterwards. So you can go here to get started with Pinecone and OpenAI as well, and also see some examples of what we will show today. Can you still see my screen?
Yep.
Yeah, I can see.
I think I need to resume share. Okay. So let me reload this. Okay, so what we can do is, what we did is we extracted the libraries from Streamlit, PyTorch, Hugging Face, and TensorFlow, and the discussion forums from them. And what we can do is now we can ask any question we like. So we can ask something like, I don't know, what are the open source models by OpenAI? And then what it will do, it will search. So it will first embed this question with the query embedding. It will then search through all the embeddings with Pinecone in a fast manner. And then it will give us the top 20 results. And what's happening here? Let's see. Oh, we have a low top K. Yeah, so what we'll do is we're using the instruction following model, which is writing a paragraph about the question. And we are retrieving the top 20 results. So we're retrieving the top 20 most likely results, and then it will write us a paragraph. So in this case, the answer to the question in a paragraph is, what are the open source models released by OpenAI? OpenAI has released several open source models, including the GPT-2 model for text generation, the CLIP model for image generation, and the WAV2VAC model for speech recognition. These models are all available in the TensorFlow Hub and can be used for a variety of tasks. We can then also have a look at where did this information come from. We can look at the sources. Because we retrieved the top 20 documents, these are the documents that are most similar. And we can then have a look at where this information came from. So it came from a combination of all of these answers. And each of these answers was obtained from the discussion on the, in this case, Hugging Face. And in this other case, it's a discussion on TensorFlow. And basically, because we are able to store a context of up to 5 pages, we can kind of store all of these contexts. And based on all of these contexts, the model figures out how to answer the question that's been asked. If you have any questions you'd like to ask the model, feel free to put them in the chat. Otherwise, I just want to show you. So when we see here style, each one of these things is basically just a different instruction to the instruction following model. And we could do a lot of other things as well. So what we can do, for example, is we can, I don't know, let's say that we want to summarize. So I think OpenAI clip has been mentioned. So it's just summarize what has been said about OpenAI clip, or what is OpenAI clip? Can it take all those questions and answers and then summarize the context so that it answers this question? So in this case, the goal of the project is to use clip to generate replies in the form of GIF to English language input. The project will involve implementing VQGAN and clip in JAX and combining various GIFs and text image datasets to train the model. So in this case, it's summarizing one of the answers, which was regarding OpenAI clip was most similar. We can also ask something like summarize all the problems given a topic of OpenAI clip. So let's say that I'm a developer of OpenAI clip and I want to know what are people struggling with when they want to run OpenAI clip? What have they said on the forum? So several problems, including how to use clip models for image search and style transfer, how to fine-tune the clip model, and how to train the model on medical data. Additionally, the questions seek to find out whether a clip model can be used to generate replies to English language text input. So by changing this, we can also say, give us a bullet point summary of the OpenAI clip embeddings, and let's see how that looks like. So then we get a summary in a bullet point list. So this is all using the same model. So we don't have a separate model for summarization. And the reason the summaries are appearing in a different format is just because we're changing the instructions behind the scenes. In this case, we're simply just asking, give us a bullet point list summary. So yeah. Let's see if we have some questions that people would like to ask. So would love to know the best practices to handle lexical ambiguity. So lexical ambiguity is generally handled if a human would be able to handle it, maybe the model would be also able to handle it. But if a human can't handle it, then the model also can't handle it. So I think there'll just be some ambiguity within the model. And also, even if the human can handle it, sometimes the model might get a bit confused by the lexical ambiguity. How do you handle embedding documents with different columns, such as separate columns for title, description, category, etc.? We just concatenate them before embedding. So that's a very good question, Kaisha. So what you can do is you can do exactly what you said. So you can just concatenate a document. And you can say title, colon, and then you give the title. Then you add a semicolon or a new line. Then you have description, colon. Then you add the description in. Then you have another semicolon, and then you have category, colon, and then you have the category as well. And this generally works quite well. So I've used this for embedding different products to be able to retrieve products and create a question answering bot, for example, or like a chatbot based on a product list. This is a question answer demo. Is embedding search the state-of-the-art way to do question answering, or is reader retrieval models like those using Google Web Snippets still state-of-the-art? Is Q&A perhaps cheaper or faster with embedding search? So that's a great question. I don't actually know what's the latest on the state-of-the-art models in this space. I think generally what we found is that at a time when so if you just ask a question in an open-ended format, in a kind of closed book format where you just ask the language model like GPT-3 an answer to a question. It performs somewhat well, but not that well. If you augment this with embedding search, generally you get a much better performance. And when OpenAI released WebGPT, which is similar to the reader retrieval model, so it's a model that can kind of go and crawl different websites, that model has outperformed the embedding search methods, but not by very much. Let's see, any questions people would like to ask based on Streamlit, Hugging Face, PyTorch, or TensorFlow? Otherwise, maybe I'll just try a few other things. For example, we can do a conservative question answer. So this model will basically say, I don't know, if it's not sure what the answer is. So if we ask, for example, what are GPT-2's strengths and weaknesses? So it will then say GPT-2's strengths include the ability to generate text that is fluent and sounds natural, as well as its ability to handle long-term dependencies well. However, GPT-2 has difficulty understanding idiomatic expressions and can sometimes generate text that is incoherent or nonsensical. It's a fairly decent answer. But if we were to ask something that might not be present in these documents, if we say, what are the strengths strengths and weaknesses of WebGPT. So I assume that there is no documentation about WebGPT on these forums. It will just say, I don't know. So this is something that you can use when you want the model to be conservative. So with the base models, before instruction following, the model will just make up an answer that sounds plausible. Whereas with instruction following, we found that we significantly reduced confabulation. So basically the model knows when it knows the answer, or it also knows when not to give an answer. And the way that we do this is we give it an instruction that says, answer the question based on the context provided. And if you don't know the answer, say, I don't know. So if the question can't be answered based on the context, say, I don't know. So then even if you ask, what color is the sky? The model is likely to say, I don't know, because it's not going to be based on the context it's retrieved. So, whereas if the instruction was not to include answer it based on the context, then the model would be able to answer, obviously. So in this case, it says, I don't know, because obviously all the sources it retrieved didn't really have anything about the color of the sky. So let's see any other questions. So there was a question about how to average embeddings. I think this question has been a consequence of previous two questions. So maybe just very quickly repeat the previous questions as well. So the question was, can you embed a single word? Can you embed a sentence? Can you embed many pages of text? Can you embed a document with 50 pages of text? And the answer is that the embeddings that we currently offer can embed up to 2 pages of text at once. And this means you can either embed a single word or a sentence or 2 pages of text. But if you want to embed a document that has 50 pages of text, what you can do is you can split the document into 25 chunks of 2 pages each. You get an embedding for each of those chunks, and you can average over all those embeddings, which then gives you an approximate representation of the embedding of the entire document that represents the meaning of that document. Averaging in high dimensional spaces generally works quite well. And if you're averaging some, let's say 10 to 20 or 10 to 100 embeddings, maybe, you're not losing too much information. As you increase that number too much more, it'll start getting more and more just kind of average.
Sorry, I was going to say there's a question in the chat here. How do I define a PyTorch tensor of only zeros? That might be quite good to test.
Oh, sorry, it's a question for this one. So sorry, what was how do I define
a PyTorch tensor? Of only zeros.
So I'm first going for the conservative question answering. Let's see if this gives an answer. Oh, you can use torch.zeros function to create a PyTorch tensor of all zeros. That seems like a correct answer to me. Would you agree, whoever asked the question? Okay, great. Yeah, if you have any other questions, let's keep those going. And I'll try to keep going through the list of open questions. So how does this differ from LFQA or RAG generative with Haystack? I've tested those and came away with very mixed results. So I haven't used any of those, so I don't really want to comment, but people who are using the OpenAI combined with Pinecone in this way have been fairly satisfied in my experience. Because you have these options of kind of specifying the instructions and being able to say exactly what kind of answer you want, so and what format you want, and also how conservative you want those answers to be. So you always have an option of backing off. So if you want to, let's say, create an internal support tool that reads all of your internal documentation, and you want that to give you answers when the answer is clear, but if the answer is not possible and you want it to refer to a human, then you can implement that with this conservative Q&A functionality. Are the style options actual prompts being used? That's correct, yes. And I'm very happy to share the prompts after the call with you for each of those styles. But yeah, each of these prompts is a very simple instruction, kind of maybe 1 or 2 sentences. They're saying do X based on the context below. And then the context below is the insertion of all the text from all of the sources that were retrieved for that question. How well does this support keyword or phrase search versus natural language queries? For example, tensor performance issues versus what are tensors performance issues? Yeah, so generally this is working on the semantic level. So it has no issue with misspellings. It has, or very little issue with misspellings, very little issue with synonyms. So if you say big and large, those 2 things will be embedded in a very similar space. So in this case, yeah, all the examples you give, I think this is exactly where embeddings shine. Is there a way to generate a list of questions that are short document answers? Yes, absolutely. So I have a prompt that does that, and I could show that to you, but I mean, that can be done just with the OpenAI API, and it's very easy to do as well. So is that worth showing? I don't know, it's maybe not fully related to this, but let me just very quickly see if I can find an example, and I'll share it. Okay. So this is just a playground interface of the OpenAI API. You can just make an API call, but the instructions here are, for example, first write 10 high-level questions, then answer each one. Use the following format. So I have questions 1 to all the way up to 10, answers 1 to all the way up to 10. Then you give it some text. Then given this text, the model will just produce 10 questions and 10 answers to those questions. So as you can see, like this is how the OpenAI instruction following works. So you create some instruction, you can even give it the format to make it easier to parse the results. Then the model will do exactly what you asked it to do. So the question around authorship attribution is very interesting. I don't think I've seen anyone do extensive research in this area. I think it will be a very interesting area to research. I've done some experiments and I found that the model is better than random at knowing, like the embeddings themselves, even without doing any fine tuning, are better than random at recognizing who authors are, but better than random doesn't mean very much. It would be interesting to give it a real test where you fine tune the model such that you tell it that things written by the same person are specifically similar to each other and things written by different people are specifically different to each other. And if you want to get in touch at boris@openai.com, I'm very happy to provide you with some code where you can do fine tuning of the embeddings so that you'll learn a translation matrix to a new space to do this. So James is typing 2 answers. So are there strong biases which make the embeddings of text of similar length look closer than text of different length? So that's a great question. And I don't think there are strong biases. and there is a slight difference between the similarity embeddings and search embeddings. Search embeddings have a much lower bias of two texts of different length that representing the same meaning, whereas similarity embeddings have a slightly larger bias towards length of text. That's, I think, my best answer. How are pages defined? Sorry, I'm not sure what pages refers to here. If you want to clarify that, please. Are there levels to how conservative? Mark, are there levels to how conservative? Oh, yes, I know what you mean. So what you're asking is, are there levels to how conservative the conservative Q&A is? Yes, it's a great question, and there's ways to control this. So the way that we've written these instructions is something like, so let me just see if I can find it. Okay. So can you see the new playground I opened? So answer questions based on the following XML. If the information is not contained within the text, say, sorry, I don't know. So what you can do is you can look at the log probabilities, and so enable the log probabilities here. So we have an XML. It has a catalog of books, and each of those books has some information. We can then ask the questions, and for each of those questions, it will give us an answer, and it will either give us an answer or it will say, sorry, I don't know. So you can see it's answering the questions, and what we can see here is, here it said, sorry, I don't know. And you can look at the probability of sorry, it's 96%. So one was very confident in its case that the answer to question 2, which is what's the best book, is not contained within this XML. And equally to question 5, there is a confidence on sorry, but the confidence is a little bit lower. So the question was, who wrote Game of Thrones? The model wasn't as confident to that answer as to the previous one. So what you can do is you can look at the log probability, and equally when you get an answer, in this case, the answer to question 4, which is what Creepy Crawl is about, you can have a look and see how likely is sorry to be present as the first token. In this case, not at all. Maybe is there another case where one was a bit more confused? Can't find one. So these questions seem to be, oh, there it is. So in the first question, what we can see is sorry had a probability of 0.02. So the model was very, very certain that the first question can be answered based on the context. And what you can do is you can basically just have a threshold set on the sorry percentage, and that can, if you set the threshold very low, the model will be very conservative. You set the threshold very high, the model will be very unconservative. And you can even set the logit bias, which then makes that, which kind of increases or decreases the probability of starting with a token sorry. That can then control how conservative your question answering system is. See, any other questions that we want to ask of the Q&A model? Otherwise, maybe I'll try something out. So let's say we want to extract key libraries and tools. Say we want to we can then only use Streamlit for this question. So kind of what we've done here. So let's say I ask a very vague question. I just want to know what are the libraries and tools I should be using for this, right? And it will then look through all the answers, and it will try to find what is semantically similar to this. Then based on all of those texts, it will extract what were all the key libraries and tools mentioned in those models. So as we can see, Streamlit is one of them, which definitely helps with building something like that. Then we have Jupyter Notebook, Matplotlib, Plotly, Seaborn, Pandas, and so on. And as you can see, it's also showing JS. And this is just what's contained within the answers that were given. And then the prompt to the model is extract key libraries and tools from the following text. Let's see, other questions?
There was one question here for the app, which is, how do I transpose a matrix in PyTorch and create a copy?
Oh, great, wonderful question. So So first I'll try with a conservative Q&A. That question may or may not have been answered. Okay, so you can use .t method to transpose the matrix and then .clone method to create a copy. There we go, that seems correct. James, any questions that you wanted to take on the Pinecone side?
Well, I don't think Pinecone is included in these docs. I mean, the questions I had before was, I think, what is the difference between TensorFlow and PyTorch? I thought was quite interesting. I think that is paragraph about a question that I liked.
So what's different?
So what is the difference between TensorFlow and PyTorch?
What's the difference? They're both popular machine learning libraries. TensorFlow is maintained and released by Google, while PyTorch is maintained and released by Facebook. In terms of convenience, TensorFlow is more convenient in the industry. Prototyping, deployment, and scalability is easier. And PyTorch is more handy in research. It's more Pythonic, and it's easier to implement complex stuff. But this might be a slightly outdated question. I would say PyTorch is very decent at everything now. Where both libraries have their advantages, and it is encouraged to learn both. Very interesting answer. I also like maybe asking something a bit more like, how can I convert TensorFlow to PyTorch? So let's say that you have some code in TensorFlow and I want to move on to PyTorch. How do you approach that? Let's see. There are a few ways to convert a TensorFlow model to PyTorch. One way is to use Open Neural Network Exchange formats. Okay, that's good. And another way is to convert a TensorFlow model to PyTorch is use the PyTorch PTF converter. Oh, I don't know about this. It's a tool that lets you convert a model from PyTorch to TensorFlow. You can then use TensorFlow oncs converted TensorFlow model to oncs. Then use. This seems, yeah, this second part seems a bit incorrect. We can then also see like which sources this came from, and there was a question about TensorFlow models to PyTorch models, and we can also kind of have a look at somebody who's actually asked that question and answered that question. The answer was just take a look at on oncs. Okay, so yeah, the model has probably read through all of these questions and figure out how to do oncs to TensorFlow. So it seems to have understood based on that question that oncs and so on was a similar topic. Let's go back to the questions in the chat. Do you have any recommendations for handling different intents for search? We do. Sorry, do you have any recommendations for handling different intents for search? We do searches for people or publications. Searching cardiologists versus heart valve replacement would both be served by different data sets. Would you put everything in the same index or do some parsing ahead of time? This is a very interesting question. I think there's multiple ways of handling this. I think what Pinecone enables is to add labels to all your documents. So you could have labels that say these things are people, or these things are medical terms, and you can filter on those first. Another way is to store your documents or when you make a search, I think the model will be quite good at understanding what a cardiologist is, and that's a person, and the heart valve replacement is a procedure. And you could have everything within the same data set, but you could also have things like more basically like you have different data sets and then you just select which data set you want to search over. You could also have something like person, cardiologist, or procedure, heart valve replacement if you really want to make sure that the model understands exactly what you want it to find. So that can maybe slightly skew the embeddings to be even more focused on just searching for people. And then obviously you can also do fine-tuning of those embeddings. It has some examples of things that should be similar versus not. I noticed with the transpose a matrix question mentioned in chat that the model will give a very different answers depending on the style selected. Not just different in phrasing, but materially different answers. What would explain that? So what explains that is basically each one of these is a different prompt. It's asking a different instruction of the model. So the model will retrieve all of these sources. And what we ask the model is, given all this information here, try to answer that question. For example, in this case, or write a paragraph about the question, or write a bullet point list summary, or summarize all the problems about a particular topic. So if we say here, for example, I don't know, so say, I don't know, so say to ask a question like this, we'll now read through all the questions. And now it's not just answering that question, it's trying to summarize the information from each of the answers to produce the final answer, which is then going to say some of the common problems of trying to run the model include out-of-memory errors when trying to load the model, difficulty fine-tuning the model on your own data, incompatibility with the transformers library. And if you were to just say, let's say, I just want a topic, which is, I don't know, what topic do I want to do? Or so I guess if you ask it to summarize, it will summarize. But in this case, I don't know what it will summarize. So if we ask this question, and then let's see what it summarizes. So the common problems of trying to use it yourself includes very similar. So memory errors on the CPU and GPU side, as well as issues with the tokenizer not properly converting to the Bengali vocabulary. So we get a different answer. If we say, I want to extract key libraries and tools, it's going to do a very different task because they're now asking to extract all the libraries and tools that it's seen within the answer. So those are Hugging Face, Flax, Arabic, JAX, TPUs, and so on. So,
so a couple of answers, questions here. I just want to quickly go through on the Pinecone side. One of those was, how does indexing work in Pinecone? Could there be billions of these vectors lying in a hyperplane? So for that, yes, we can handle billions of vectors, and Pinecone is using a proprietary approximate nearest neighbors index to actually do that with to that sort of scale. There was a few others to find.
There was a question about the architecture. Do you want to take that one, James?
Yeah, where is that?
So the last question, can you review the architecture again with OpenAI and Pinecone, both when indexing the documents and
And the pipeline from questions, served and responses. Yeah, so for this, when we're indexing the documents, so what we have is just a simple web scraper that's pulling in all of these. You saw the pages before when we were on the sort of TensorFlow community page, and we were just pulling in like a question and then any answers that appeared underneath that. We're pulling those in as a single sort of chunk of text, or as a question and a set of answers, and then feeding those as a page into the OpenAI embedding model. That produces our sort of what we've been calling context vectors or context embeddings throughout this, and then we saw those in the Pinecone vector database. Then that gets stored there, so that just stays there. So Pinecone just running, you have your index, you have all of your context embeddings in there. And then you move over to the querying side of it. So querying is where we have our Streamlit app, and we just have, okay, we have a little search bar, type something in, and then as soon as you press enter, that is passed into or passed over to the OpenAI embedding model through the OpenAI API. That then returns your query embedding, which we then send over to Pinecone, which returns our context embeddings, which we then structure in. You can see it in the, you'll be able to see it in the resources for this set of slides. but it structures it into a string where we're asking a question like, can you answer this query and return a simple bullet point list based on these contexts that we've returned? And then we list all those contexts, and then we return the answer that you've been seeing in the demo. Yeah, I don't know if there's anything else to add to that. Just ask another question if there's anything missing.
Okay, great. There's a question, why do we have query embeddings and context embeddings separately? So we could just use the similarity embeddings and kind of treat everything the same. But what works best when you're generally these questions are very short, whereas documents are very long. So that's why using a different query and context embedding is better. And this is based on how the model was trained. So when you train these transformer models, you can specify what the query is and then what the context is. So for example, the query could be the title of the document, whereas the document embedding is the entire document below. So the model learns that queries tend to be shorter, but they need to match the longer context. That's why we do that.
There's another question here. Can this design handle work in very large documents? And does Pinecone handle the splitting and pre-processing? So Pinecone is just handling the embeddings that you're feeding into it. And then in this case, the OpenAI embedding model is handling that embedding. And I'm not sure what the largest size is for that.
So it's about two pages of text.
2 pages.
And for splitting and pre-processing, we have some document, like some Python code we can send, but generally, like, you can do this yourself. You can split it on like full stops or on paragraphs, and you're just going to make sure that everything is less than 2,000 tokens. Okay. Do you have a reference to the difference numbers between search embeddings and similarity embeddings? So you can find all that in the paper. I think I shared the paper in one of the answers, and you can find it on the OpenAI embeddings paper. So let me just link it again. There we go. I'll just answer the question. So this is the paper. This paper goes into the detail of comparisons of similarity and search embeddings for different tasks. You talk about pages in the context of making embedding. Are pages a size limit? So no, the size limit is actually 2,000 tokens. And I'm just giving pages as a kind of rough estimates. 2,000 tokens is maybe about 1,500 words of English. So that's kind of where this comes from.
There's a question here. Is it possible to show a list of evidence that led to the generative answer that was returned? I think, Boris, we can see that in here when we open the sources panel, and that would just return a link to all of the sources that were returned from Pinecone and then fed into the generative model. So we'll see this now.
So let's say we say compare and contrast TensorFlow and PyTorch, and then get an answer. Let me just, oops. I was going to use the PyTorch and TensorFlow communities to compare. So I think what I like here is we want to compare and contrast TensorFlow and PyTorch, but we're not wanting to include anything from Hugging Face or Streamlit that may mention both. I would expect that PyTorch will be mostly mentioning PyTorch and TensorFlow will mostly mention TensorFlow. Then it says they're both major machine learning libraries and so on. And we can have a look at the sources. And in order to understand this, we'll have to actually read through all these, 10 different discussion pages. And TensorFlow models, 2 PyTorch models are extended with PyTorch. There may be some kind of description. Okay, TensorFlow JS and Py was the difference. There might be some things that kind of showing different. Oh, how is PyTorch different from TensorFlow? That's, I guess, the top question. So if we were to leave the top to just one, it wouldn't just use this first answer. I would assume that this answer will give us something quite decent. So yeah, TensorFlow is more convenient in the industry. PyTorch is more handy in research. So this is where that one answer came from. So you could manually look at it but the model itself doesn't explain what it does. What we could do is we could change the instructions to also cite where the information came from, or to explain, like quote the paragraph where the information came from. And generally the instruction following models are quite good at doing that. So we just need to kind of, in this case, add another style, or basically just change the instructions to specify, answer the question, and then explain your reasoning and show where the information came from. And then the model would hopefully be able to give some of that. Not all perfect, but some it will get somewhere. Okay, so this is a really good question. So from your experience in answering questions of a knowledge base, is it best to index text on a page level, paragraph level, or sentence level? So I think from my experience, sentence level is not very good, because if the question, like some documents will be formatted in different ways, and sometimes you need to understand a few sentences before you can actually answer the question somebody asks. So if I ask a question of how does TensorFlow differ from PyTorch, you may want to have some more context rather than just a single sentence that talks about one or the other. So I think somewhere between, I think half a page is what I normally go for, so about 500 tokens. And that's what I found to be most useful, but I think it will depend a little bit on your context. If you're only asking factual questions, you may want to go down to, let's say, just a single sentence. But if you want to go maybe towards maybe more legal documents where you need to understand like 3 clauses in order to be able to understand the meaning, then you'll probably want to go towards the full 2 pages of text. So I guess that's my reasoning. And normally what I go is somewhere between a paragraph, half a page to a page, I would say is probably the best range. What's the average word length in a page, or what's the recommended word limit for 2 pages? What's the average word length in a page? So I think it's somewhere around 1,000 words or 800 words per page. Basically, it's about 1,500 words is about 2 pages, which is about 2,000 tokens. Any recommendations for re-embedding evolving datasets? Yeah, that's a great question. And it's something that Pinecone does very well, which is updating the embeddings themselves. And if you have a dataset that keeps changing, what you can do is you can either re-embed every time there's a change, or you can compare the difference. What's the edit distance between the first document and the second document? Or what's the n-gram similarity between the 2 documents? And then if the similarity is very high, if it's, let's say, 90%, you don't re-embed, but if it drops below 90%, then you do re-embed. So if somebody's just changed a few words, probably not cost effective to re-embed. Okay. Let's see. What kind of processing does Pinecone apply to the vectors that are fed in? Does it apply some kind of quantization or compression? And if so, do they have a negative impact on performance?
So, well, it's proprietary what Pinecone is doing, but the what is being done obviously makes it so you can scale very well to sort of billions of vectors. But in terms of performance, it's very good. You use very little. Like your accuracy is very close to what you'd be getting with an exhaustive search.
Okay, maybe I'll just take the last question, which is at the beginning of the talk, I said that the distance metric doesn't really matter. So in my experiments, using dot product or constant similarity, they result in a very similar performance on a variety of tasks. So why is that the case? Because this is a high dimensional space. In a high dimensional space, things are very different to each other. So even if you use a taxi distance or any other kind of distance, Hamilton distance, you will find that the results are very similar to each other. Does the dimensionality of the generative model and the embedding model have to match, or is there even some functionality maps from one to the other? No, so this question is an interesting question. So the generative model has no connection to the embedding model. So what we use the embedding is just the search and retrieval part. We then put the text from what we retrieved into the context of the models. There is no need to match the dimensions. But what you can do is, this is an interesting question, which is if you want to combine, you have a document base, you want some documents to be incredibly high quality embedded. You may embed some documents with the query embeddings, some other documents with an ADA embedding, which are less important. Then you can try to learn a function that goes from ADA embedding to the query embedding. And you can just try to learn a translation matrix, which won't be perfect, but it may do a decent job. there. Any other questions? So I think we're maybe over time. So thanks a lot for all the questions.
Thank you all so much for your questions, and thank you, James and Boris, for this incredible presentation. As noted, you will receive the slides, demo notebook, and the recording in an email either later today or tomorrow. We hope to see you at our events in the future. Thank you all so much.
Everyone, bye.
Thank you so much. Bye.